Okay, so class number 6, definition of the natural log function. So natural log is written as ln, and t is the input. ln t, by definition, that is very important, is the area under the function 1 over x for x positive from 1 to t. So as we mentioned earlier, the graph of 1 over x. So here, x is the input, so that horizontal axis becomes x. So the graph of 1 over x looks like this. 1, 1, 2, half, etc. It is the area under this function from 1 to t. So that is the starting point. And t can be any positive number, because I am looking at the area under this curve, and that curve has a meaning from x bigger than 0. So for example, if t is 1, then I am looking at the area from 1 to 1. Well, there is no area because there is no width. So ln 1 when t is 1 is 0 because there is no area. And when t is 2, well, ln 2 is the area from 1 to 2. So it is this area. And that is less than 1. So ln 2 is some number, but that number is less than 1. But that is bigger than half. So that rectangle has area 1/2. Its width 1, height 1/2. And this green area is bigger than the black rectangle. So this area is bigger than half. Okay, so it is actually 0.7 something. But anyway, that's ln 2. It's not quite 1. And as I mentioned in the previous lecture, as we go along, as t increases, there is a certain number t such that this area becomes exactly 1. And that is number e. When t is e, that area becomes exactly 1. So that was the definition of Euler number. So ln e is 1. Okay. So as you can imagine, if t increases to the right of 1, when t is on the right of 1, ln t is bigger than 0, and ln t will keep increasing. ln t, the value of ln t will get bigger and bigger because the area gets larger and larger. But if t is on the left hand side of 1, so if t is here, let's say t is 0.5, then we measure the area from 1 to 0.5. So the width is still this area right there, but since we're measuring it from 1 to 0.5, width becomes minus 0.5. So we get a negative area. And as t gets close to 0, you see that my area increases and it becomes more negative number. As t gets closer and closer to 0, I get more negative area. So from there, we can make the graph of ln t. So this is very important. Graph of ln t is the following. So this is t, and that's the ln t. When t is 1, the area is 0, 1. When t is 2, area is approximately, so let's say this is 1, it is less than 1, so it is somewhere here. When t is e, then the area is exactly 1. It should be, e is approximately 2.78 something, right? So it is somewhere here, then it is 1. And as t gets larger, this is getting bigger and bigger. And as t gets close to 0, I get negative area. And as t gets close to 0, I get more and more negative area. I have a steeper decrease. So this is the graph of ln t. So that is very important. Memorize. Domain. Domain is set of all inputs of ln. So the domain is t positive. It can be any t bigger than 0. Range is collection of all outputs. So as you see, as t is bigger than 0, I get all possible real numbers as its output. So the range of ln t is minus infinity, infinity. Okay, so all these are very important. They will come back later. Domain is t positive, range is all real numbers, minus infinity to infinity. And if you see the graph, I see that it passes vertical line test, so it is a function. Moreover, it passes horizontal line test as well. So we see that the function ln t is 1 to 1. So its inverse is again a function. It has inverse function. Okay, so yeah, it is actually on the next next page. So we call the inverse function ln t as, do you know what it is? ln t as exponential function. Exponential function is the inverse function of ln t. And we denote that as exp of t. So let's look at the graph of ln and its inverse function. So t is my input variable, right? So the graph of ln is this one, that's e. At e it is exactly 1, and this is ln t. So this goes through 1, 0, e, 1, etc. And for inverse function, we have to switch these two. So when input is 0, output is 1. So this point in the ln corresponds to 1, 0 in the exp of t. And this point in ln, that is e, 1, corresponds to 1, e. 1, e. So 1, e here. Okay, so that is actually, if you see it, we have to switch x and y, so it's a reflection. We get mirror image reflection about the line y equal to x. So this graph of ln gets reflected over, let me use gray, reflected over to the line y equal to x. So that is the graph of exp of t. exp of t. So you have to memorize the graphs of both. So what is domain of exp of t and what's the range of exp of t? So for ln t, what was the domain? Domain was t bigger than 0. So if I write that in interval notation, it is open 0, infinity open. And range was minus infinity to infinity. Since we are swapping inputs and outputs, the domain of exp of t will be 0, infinity. Oh, no, sorry. Right, it's not this. Domain becomes range of ln, right? So it is minus infinity, infinity. And the range of exp becomes the domain of ln, so that is 0, comma, infinity. Okay, so all these are very important. Yeah, remember those.